Hello, and welcome to 5-Minute Math. Today we are looking at the lessons learned from the 7th grade 2023 STAAR test. My name is Aaron Daffern, creator of the 5-Minute Math videos, and we're going to be looking at the readiness standards in which the state of Texas performed at less than 50% mastery across the state. If this looks like an awful lot of readiness standards, then you are correct. This is every single readiness standard except for 7.6H. So that means there was a lot of struggle on this test. We will look at why they got the questions wrong and what are the instructional implications for us as educators. So let's start with the readiness standard that we had the most difficulty on. This is 7.6G. You notice we had only 28.5% mastery overall. We're looking at bar graphs and circle graphs. And so we only had 32% correct on number 12 here. And we had to figure out 60% of the sales. And what that means is we had to, add all of these up, right? We had to take 18, we had to take 15, we had to take 21, we had to take 6. We had to add all those up, right? And then we had to find 60% of those. So add all these up, and we need to find 60% of that. And then we had to find two different brands that added up to that 60%, right? So that's going to be these two are going to be 33. That's going to be 27. Right, so that's 60. So 60% of that is going to be times 0.6. So that's going to be a difficulty for some of these students is how to find 60% of something, right? Multiplying by a decimal. And then hopefully we see 36, but now I've got to find a combination of two that equal to 36, and it's going to be this brand B and brand C. So that's going to be the answer on that one. But we had to do a little bit of addition. We had to find 60% of it, and then the answer wasn't just what is 60%. The answer is which two, car brands represent 60%. So now I have one extra step of adding two to find that 36. Over here we have a number 28. We had a multiple select here or hotspot. So we had three correct answers we had to choose, and only 25%, one out of every four students, got both questions correct. It's a 2-point question, but we did have almost half get at least 1 point correct. So you put those together, we're getting close to 75%. So the low score on this was those that got all three correct answers. And so what we needed to do was we needed to find, we have 50 plants. We needed to put a percent and a number for each of these, right? So we know that tomato plants is twice the bell pepper plants. So if the bell pepper is 16, then I can say this is going to be 32%. And then I need to see, okay, what's remaining because watermelon and cucumber are equal. So these two are going to be 44 and 16 is 60. So all of this is 60%, which means these two are going to be 40%, right? So if I split that in half, that's going to be 20% and 20%. Now, that would be helpful, except I also need to find actual numbers, right? So now I need to find the percent of, 12% of 50. So I'm just going to start with this 16% of 50. Because what I'm going to do is I'm going to double that to get my 32. So that's going to save me a step. So that's going to be 300, right? So there's your 8, right? So I'm going to double this to get my 16. And then I need, 20% of 50. So that's going to be 10, 10, right? And if I want, I can just subtract that. That's going to be 24, 34, 44, which leaves me only 6 for squash. Now, after all of that work, I'm ready to answer the question. The number of tomato plants is 16, right? That is correct. Got that right there. Total number of cucumber and bell pepper plants is 18. Cucumber and bell pepper is 18. Yep, I've got a 10 and I've got an 8. Over 50% of the plants are tomatoes and bell peppers. Tomato and bell pepper is 32 and 16. That's only 48, so that's incorrect. Watermelon and cucumber plants combined are 40%. That is correct. And cucumber plants are 26. They're only 20. So those are my three answers, but you see all the work I had to do before I can even select those. So let's see what that means for our instruction here. Right, so what made it difficult? That's going to be in the gray part up here. So on the bar graph, we had to find multiple successive operations. We had to add, then we had to multiply by the decimal, then we had to add again to find the bars that added up to that percent, right? That 60%. And that correct answer, like I said, it was that very final operation. We didn't just need to find that 36, right? We had to go back and then we had to find the two brands. We had to have that final, let's add two things. So even that added a little bit of complexity here. We had to convert our circle graph from percents to actual numbers. That made that difficult. And this multiple select. If you don't really feel like working too hard, you can just kind of eyeball it. Or at least it looks like that, right? If we were to take all of this away here, right, let's just look to see what it looks like. It's just going to look like, look, there's only 5 answers. I only need to select 3. So this looks okay, this looks okay, this looks okay. So that's why I'm thinking we probably had a lot of students to get partial credit because only 3 out of 5 probably encouraged a little bit of guessing for our students. And so what are the instructional implications? Those are going to be down here in white. So we just need to practice just the straight algorithm of how do you find a percent of a whole? So what is 16% of 50? What is 28% of 100? And have students practice, get very comfortable with, converting the percent into a decimal and then multiplying that. And then when solving bar graphs, we need to practice, finding the percent of the graph, like 60% of total sales, like they did in this problem, where the answer is not just what is 60% of the total sales, but which 3 combinations, like we had in that problem. We need to mimic that because sometimes we're just trying to get them to add up the total sales and then find the percent of what's 60% of that or 70% of that. But the answer should be an extra step of adding 2 different bars like they did in the problem. And then before we even look at a circle graph, especially if they're going to have, the hot spot where they can choose 3 of 5, students should be encouraged and trained to fill in the graph with both a percent and an actual number before they even do anything. Much like I solved that problem before I even looked at it and was trying to evaluate whether something was correct or incorrect. If I see a circle graph, I'm going to fill the whole thing in with percents and numbers before I even get started. For the next set of problems, we're looking at 7.7a. We only had 32% overall mastery. We're looking for linear relationships, how to represent them, and we wanted to represent them in this case, these two problems, number 7, number 25, with tables. So we're looking at this slope-intercept form here. Number 7, we did okay, 52% correct. So we needed to find how we could take this verbal description of a bowling alley situation, right? So we have 650 per game. So that per game is going to give us our rate, right? So it's going to be y equals 6.5. And then x plus, and then it's $4. That's just going to be it's kind of your constant right there. You're not multiplying that by game, right? And then, of course, they would replace the G for the X, the C for the Y. So you end up getting the cost equal, 650 per game plus 4. And then you needed to substitute in, well, what happens when you've got 1 game, when you've got 3 games, when you've got 5 games, right? So 1 game is going to be that 1050 because it's 650 plus 4. But then you add another 2 games, that's another $13, right? That's going to get you $23.50 because now that's 3 games. Then another 2 games, that's another $13. That's 650 times 2. That's going to get you that $36.50. So that's your B right there. Over here is going to be a drag and drop. And you see we've got this mx plus b, but all we have is a table of values. So what does that do? Well, first off, we should be able to say, okay, the b is the y-intercept. And when x equals 0, then whatever the y is, that's going to be my y-intercept, that's my b. So we could put a -3 right there. Now, to find the m, that's the difficult part, because if you look on the reference materials, we don't have this m equals, right, the change in y over change in x. So we need to know that going in. Right, so we're going to take 2 different y values. So let's just take these 2. And then let's take 2 different x values. Let's take those 2. And we'll subtract them, right? So -4 minus, and then a -3. And then I've got a 3 minus 0. So that's going to end up being, adding. So -4 plus 3 is going to be -1 over third. So I've got this -1/3. So that's my answer there. You notice that we had only 12% correct. Only 12% of our students got both of these answers correct. And even if you take on that partial credit where you get 1 out of 2 points, only 29%, right? So we're looking at 41% getting 1 or 0 points. That's really low. So what does that mean for us? Well, that means that we need to do a little bit of work here because it was difficult. It was difficult because we see that in the gray boxes up at the top here. We had to interpret this in the very first problem. We had to interpret the slope-intercept form from that problem situation. We had to see that we're in a bowling alley, right? And that somehow equals y equals mx plus b, and that the shoe rental was going to be my b, my constant. And then in the second problem, we had to calculate slope. And once again, like I said, that's not in your reference material. So we had to know that, m could be calculated from the change in y over the change in x, right? The rise over run. The y-intercept, we needed to recognize that that was in the table, right? Then when that x is 0, and that we could use that as the b. And so what does that mean for us as educators? So we need to practice, first off, converting from problem situations like the bowling alley situations and turning that into, an equation so that we can calculate a table of values. Sometimes we might just have them take a problem situation and turn that into an equation, and that's it. But that first problem had us do another step of first off creating the equation, and then secondly, turning that into a table of values and then matching. And then finally, we need to obviously help students, find the y-intercept. If given an ordered pair, we need to recognize that if x is 0, y is going to be b. That should be something that we instantly recognize. This is our big one right here. Just practice finding slope. Change in y over change in x. We need to just practice just that raw calculation so that we could use it in problem situations. All right, so the next standard we're looking at is 7.9c, 34% overall mastery. We are looking at composite figures or missing sections, right? So what do we have here, number 13? Well, this is difficult simply because, you got a composite figure, but now we've got this this equation editor. So we don't have A, B, C, or D to choose from. We just need to figure out what the area of each of these trapezoids are, right? So how do we find the area of a trapezoid? So area equals that 1/2, and then we've got the two bases together, right, over the height. So this first one, right, is going to be, here's my two bases. So this is going to be 1/2, 7, and my height is 2. Right, so that's going to be, if I take my 1/2 of my 7, that's like 1, so that's 7. And then I'd get the same here. I've got 1/2, and then 3 and 5 is going to be 8, and then another 2, so 1/2 of 2 is just 1. Right, so my answer is simply going to be 15. But there's no verification of that. If I get 16, if I get 18, I'm just going to type it in. I can't do a self-check to see whether it's one of my 4 answers. Now, what do we need to do here? We need to find the dark pieces, right? So what do we know about this? Well, we know the whole thing, right, is going to be 39 times 29. So we can at least figure that out. Now, in 7th grade, we don't have the calculator, so we need to do this, by hand. So 39 times 29, that's going to be 1131. And then what I'm going to do is I'm going to subtract the area of my white pieces. I've got 1, 2, 3, 4, 5, 6 of these strips, and these strips are going to be, length times width, 3.75, that's the 3 3/4 times 39, right? So 3.75 times 39, that's 146.25, and then there's 6 of those. So that's 877.50. You notice that that's one of my answer selections there. So we could have done all of this work and got it wrong because we found the combined area of the white. What we need to do is we need to subtract that from 1131, and that's where you're going to get your 253.5 or 5/10. So our answer there is D. So what does that mean for us as educators? Well, first off, these were difficult because, the area of the trapezoid formula is a little bit more complex, right? Because you've got to do the 1/2, but rather than just base times height, it's the base sub 1 plus the base sub 2. So we had to recognize the bases. And then, once again, the equation editor provided no confirmation of whether the solution is correct or incorrect. You just had to type it in there. And then, in order to find the calculations required for the area of the dark wood, look, I'm making this video and I did all of that with a calculator while I'm talking to you. But all of these right here had to be done by hand by students because they could not use a calculator. So they had to multiply this 29 times 39. And then they had to multiply the 146.25 times 6. And then they had to subtract that product from this product. That's a lot of calculations. And every single time you calculate, obviously there's an opportunity for making an error. And then number 26, right? It's going to be that second one. The answer distribution, as we look at the guesses or the answer selections here, it really just suggests guessing, that most likely the students were just kind of guessing on that one. So that means we need to do several things, and you see them in the white right here. We need to provide many opportunities for finding the area of composite shapes. The one that they had here had two different trapezoids, but you could have a trapezoid right on top of with a triangle sitting on top, right? Have use two different to use two different equations, not just, two trapezoids or two triangles or two rectangles. And then when we are given this, find the removed portions of the shaded, the unshaded, have students set up equations to find the area of both, and then have them find the area of both. But the difficult thing sometimes is just setting up the equations. So break it down into those two steps. First, set up the equations for finding, the shaded regions and the unshaded regions. Then let's go ahead and calculate the shaded and the unshaded. Because if you want them to find the area of the unshaded and they get it wrong, you don't know whether it was a calculation error or because they didn't set up the equations correctly. They weren't sure how to exactly find that. So break it down into its component parts. That will help you diagnose issues that students might have. So looking at our next one here, we've got 7.6i, and that is 36% overall mastery. We are using experimental or theoretical probabilities related to simple and compound events. So this one, it's not as difficult as it seems in regards to calculation, but we do have to recognize something right here. So we've got a geometric solid, number 16, and it's rolled 30 times, and we've got our little array here, 3 times 10. We're looking for the experimental probability that will land on a 7. Now here's where it becomes difficult, right? Theoretical is going to equal, well, it's an 8-sided die, and it's got the numbers 1 through 8, so it's a 1 to 8, but I'm not looking for the theoretical. I'm looking for the experimental. And the experimental means how many 7s are there? I see 1, I see 2, that's it. So I've got 2 out of 30, which I need to simplify to 1 out of 15. So that's the challenge right there, is just recognizing the difference between experimental and theoretical. And of course, the theoretical is going to be one of our answer choices. And then number 30 here, only 26%, got this correct. So we need to randomly select a sandwich that's got white bread, so right there, ham, right there, and then cheddar cheese right there. So we could make this huge sample space, or we can just, multiply here. Well, I've got a 1 out of 2 chance of getting my white bread. I've got a 1 out of 3 chance of getting ham, and I've got a 1 out of 2 chance of getting my cheddar cheese. So we can multiply that, and that's going to be 1 out of 2 times 3 is 6, times 2 is 12. You could also create the sample space. You would get 12 different options. So my answer here is D. But take a look at that, 26%, just a quarter. So let's see what that means for us as educators. Well, we had to find the experimental probability on the first one, but the theoretical probability was also an answer choice. And take a look at that. It fooled a quarter of our students. So just looking at the difference between those, making students aware that they can do both, but they're only going to be required to find one. And then this compound probability confused many students. So look at this. 37% of our students chose the number of choices available. Remember that the percent correct was 36. So more students chose this than the correct answer. And they really, looks like they didn't know how to set it up. They just said, oh, there's 3 choices, so 1 out of 3. And that required no calculation. So they probably just made it simpler than it needed to be. They didn't calculate. They just thought 3 choices, 1 out of 3. So what can we do as educators? We'll take a look at these suggestions in white at the bottom here. We need to provide students with some data, some experimental data, but like we did in the one with rolling the die, have them find both the experimental data and the theoretical data, the probabilities of both, and discuss the differences. So they get used to comparing and contrasting the two within the same problem. That will help them discriminate between those options in the future. And then I saw the compound probability with just the basic mathematical calculation, but you should have them do both the tree diagram, create the sample spaces, and the mathematical calculation. So really good double check to make sure that what you're doing is going to be correct, because the 1 out of 3 should have been a red flag. That's a bit easy. All right, so let's look at 7.4a. You see we've got 40.5% mastery. We are representing constant rates of change, right? And this one, number 9, was a little bit difficult, only 38% correct. You see that it's the graphing, right? And I'm finding this in my own review of STAAR tests of various grade levels. This is probably one of the most difficult new item types. It's not super intuitive, right? So the answer is going to be, it's just 1 point. You either get it correct or incorrect. We need to create a line, but the way we do that is we select 2 points. Now we can select any 2 points on this on this graph that would get it for us, but they only give us 1 point really here, right? So a distance of 20 inches in half an hour. Okay, so here's my 20 right here, and then my half an hour is going to be right here. So one thing that might not be super intuitive is that you can actually use that half. Okay, you don't necessarily have to be on one of the whole numbers for time. And now you need another, the second you put another dot, it's going to create a line for you, right? So you can double that, right, if you wanted to do that. So that's going to be 1/2 20. It's going to be 140. You could do 280, right? So now we've got a line. And if you want, you could also, make it goes through the origin. You could start there, and it just, whatever this line is, right? This is going to be the correct answer. So that line itself is the correct answer. Okay, so let's look at number 23. And this is a, multiple select. We need 2 out of 5. And we only get 43% that got it fully correct, but take a look at this. We had another 43% that just got 1 point. So you take those together, we've got 86% of our students getting, 1 or 2 points. That's pretty good, because the basic rate was, 80 over 5, right? 80 over 5. So that's going to be pretty basic, right? So that turns into this y equals 16x. And then I think most of the students got that correct. What we need to do is we needed to now represent it as a graph, and that's going to be this bottom one right here. And we're just basically, right, just turning, just putting some points in here, and we could see that it's going to be right there. It goes through the origin, and it's 80 over 5. So let's see what this means for us as educators. And so The graphing online tool is not 100% intuitive. I think that's one thing that we need to help our students practice and understand what that means of how do we use this graphing online tool, because it works when you put two dots on there and you have to create your own dots. And it's not visually clear, right? That students can choose the 1/2 as an x-coordinate. So I did that with a little bit of experimentation. The students could do that as well. But if that didn't work, right, if you didn't have that 1/2, well, then you're going to have to take that 1/2, right, over 20, right? And if that's going to be your x's and that's going to be your y's, right, then you're going to have to, come up with your own coordinate pairs, right? 1, 40, right? You can take the 2 and 80. You're going to have to come up with two of your own. And if you recognize the origin, right, you also, could do 0 and 0. That could work as well. So you had to kind of figure out that you could use this 1/2 as an x-coordinate. And then multiple select, right, allows for greater confidence with guessing, because if you know that you have to get 2 right, that is on that second problem going to kind of encourage our students to not do so much work because they've got so many options to choose from. Now, what we need to do to help our students to mimic that graphing new item type is just provide them with coordinate grids, most likely pen and paper, and just have them plot constant rates, providing them multiple points and using various scale factors. Because take a look at the scale factors on this first one, right? So on the scale factor on the x-axis, you're just, counting by ones, but look, you're counting by 20s up here. So that might have messed them up a little bit. But they just need to plot the points. If they can plot the points and actually create the graph, drawing a line with a straight edge, to show what that graph actually looks like, that's going to provide the practice they need for that particular item type. And then, you know, we need to give students a constant rate in a problem situation. So just like we did, right, this 80 over 5. But you notice what made the second one difficult was that it had multiple representations. So they had to, find an equation, table of values, and a graph. So we need to give them those problem situations, have them do the same thing, right? Create a table and, draw an equation and then graph it. So provide those opportunities where we take this constant rate in a problem situation and then represent it in multiple situations. Or maybe we give them a constant rate in the direct variation form and they write a problem situation and then they create the table and graph it. So they need practice creating and converting these problems into various forms. So next, 7.12a, that is 42.5% overall mastery. We're comparing groups of numeric data. So we've got box plots, we've got dot plots, right? And so what we needed to see here, obviously we've got median, we've got maximum, we've got range, we've got interquartile range. This is a vocab problem as much as it is a problem about actual calculation, but that vocab is going to be very important. And what we needed to see here is that the IQR on Monday was equal to the IQR on Tuesday. So my IQR on Monday is going to be, 50 to 80, so that's 30. And then the IQR is going to be 50 to 75, right? That's going to be 25, right? So now we're just eliminating here. The range on Monday was equal to the range on Tuesday, right? So obviously we should be able to do that without calculations, right? Take a look. That range is going to be shorter, 30 to 85. This also goes to 85 on Tuesday, but you notice it starts at 20, so that's not it, right? The maximum typing speed on Monday was greater than the maximum typing speed on Tuesday, so now we're just looking at those 85s, right? And that's incorrect. And then we've got the median on Monday was less than the median on Tuesday. And so Next, we're looking at 7.12a. We've got 42.5% overall mastery. We're comparing groups of data. In the first problem, number 10, we only had 43% correct, and we're looking at dot plots. And really, it's a vocab problem. Median, maximum, range, interquartile range. If you don't know your vocabulary, you're not going to be able to do much with this. There's a little bit of calculation, but mainly it's just about the vocab. The correct answer here is we need to look at the interquartile range. We need to recognize that as either end of the box, right? So that's your 55 to 80, right? That's 25. And then you've got your 50 to 75. That's also 25. So the correct answer is that the two IQRs are equal. D, right? And then over here on number 32, we needed to see that we've got, the 42% full credit, that's both points, 17% partial credit, that gets you just 1 point. So 59% gets at least 1 point. So this first drop-down menu is looking for whether it's symmetrical or asymmetrical, right? And so hopefully we see that both of these, that's not really symmetrical. And you notice we got these peaks and valleys, but that might be something that we don't necessarily work on too much, but we could not draw a dotted line down any of these, fold them in half, and see the exact same thing. So this is going to be, asymmetrical. And then we need to see that on the second one, both groups have the same median, mode or range. The median was a little bit difficult to calculate. The mode was a little bit easier. Obviously, they have different modes right there, right? It's going to be that range, right? The 10.5 to 13.5, 10.5 to 13.5. It's one that you can just, you don't really have to calculate that. You can just see that they both have the same beginning number and end number. So asymmetrical and range are going to be the two answers here. So what did we learn about this? Well, students had to apply various concepts, but we had domain-specific vocabulary. Median, range, interquartile range. We have to know what those terms mean before we walk into this problem. And then evaluating statements and then finding the one that supports requires up to 4 times the calculations, right? Rather than just say finding the median, right? We had to do a calculation on all of these before we found the one that was correct. So those problems can potentially be 4 times as long as one that says find the median, and that could be a stamina issue. Sometimes students just get a little bit over having to calculate every single answer choice to see which one is true. And then obviously interpreting the box plots assumes understanding of quartiles, this IQR, this new item for 7th grade, or new standard for 7th grade. It's always a little bit difficult. So in addition to, what can we do? Well, we can get them practicing multiple things, right? So in addition to calculating the range and the IQR, we need to have students find the range of individual quartiles, right? So take a look at this box plot. We could have gone back and said, hey, what is the range of this second quartile, right, for Tuesday, right? So the second quartile is going to be from that 50 to that 65. So that's a, second quartile range of 15. Do they really understand these quartiles, or do they just look at lines and boxes? Because sometimes we go straight to the IQR and they're looking for either end of the box, but they don't really know what those quartiles mean. So we need to provide them a little bit more experience with just the quartiles themselves, and we need to provide them opportunities to calculate median. Median was the difficult one to calculate, and that was ultimately an incorrect answer on that second one. But how do you calculate the median on box plots, on dot plots, and with just raw data, both sorted and unsorted? Obviously, if it's sorted, it's going to be easy. But how do they find the median with the unsorted? So this is a term that requires a little bit of work of sorting, and this should be something that we provide extra opportunities for, because that's one that sometimes gets missed when that is the correct answer. 7.11a, we are looking at only 42.5% overall mastery. We're modeling and solving one variable equations and inequalities. We should be thinking, if we see an inequality, are we going to flip that inequality? It's a common trick that we have in 7th grade to try to make it more difficult for our students. But before we even do anything, right, we want to isolate the variable. Take a look. I've got a negative 5x and a positive 4x. So I need to combine the like terms. I got negative 5 plus 4. That's going to end up with negative x plus 4. So that's something a little bit new for some of our students is we've got two x's we need to combine there. Now we're going to, isolate this variable here. So let's get negative x is less than or equal to 8. And then you either, multiply by negative 1 or you divide by negative 1 because you don't want a negative x. You don't want a negative as the coefficient, right? So that's going to end up being a positive x. We flip the sign, right? So that's the big thing here, and it's negative 8. So we're looking for the one that does not belong in the solution set, right? So if here's 0, here is negative 8. I'm looking for x is greater than, so I'm going to include negative 8, greater than or equal to negative 8. And then as we see here, I've got negative 7, I've got negative 6. Those belong. It's the negative 9 that does not belong. So that is my answer right there. And then we see here this equation, and nothing looks like it's negative, right? So we're just going to have to assume everything's positive. So these are x's, and that's a 1. All of these are 1s over here. So that's going to be 3x plus 1 equals 7. Now, once we have that, that's pretty simple, right? We're going to subtract 1 from both sides. 3x equals 6. Divide by 3. So x is going to equal 2. So our answer there is C. We did a little bit better on that one. We got 47% correct. So what does this mean for us as educators? Well, we had to invert the inequality because we divided or multiplied by a negative. That's going to always trick us. And we had to simplify like terms. So that made it a little bit more challenging for students before we started to isolate for the variable. And then obviously anytime we have an algebra tiles representation, that can add a little bit of complexity because, if it just started with 3x plus 1 equals 7, that's not that big of a challenge. But even trying to find that from algebra tiles makes it a little bit more challenging. So what can we do as educators? That's going to be in our suggestions in the white font at the bottom, right? So we need to provide students with problems that require them to combine like terms first. Let's get, negative 3x plus 2 minus 5x equals 18, right? Have them combine the x's before we isolate for the variable, right? I didn't do this in our explanation, but always check work with substitution, right? You could plug in that negative 9 back here, just to make sure that it doesn't work, right? So we can have this negative 5, and we can do negative 9 plus 4, negative 9 plus 4, right? So that's going to be 45. It's going to be minus 36 plus 4. It's going to be 9 plus 4, right? So that's going to be 13 is less than or equal to negative 12, right? But that's verification. So we need to have students be doing that as well. And then how about we do the reverse, right? How about we give them an equation or problem situation, maybe even an inequality, have them turn that into a representation using algebra tiles. That will help them get a little bit more flexible with algebra tiles because typically on the STAAR test, they're going to be given algebra tiles. They need to translate that into an equation or inequality. Let's reverse that. We give them the equation or inequality. They convert that into the algebra tiles because sometimes the coefficient, right, the 3x, realizing that, we need to, if we're using these rectangles as x's, even just representing it like that could be a little bit confusing for kids. So giving that opportunity to go from an equation or inequality back to algebra tiles will be helpful. So 7.4D, we're still stuck on 42.5% mastery here, and we are solving problems with ratios, rates, percents. And so we've got this number 1, we have 50% correct, so that's not horrible. It was that number 21 that really kind of messed us up here. Right, so we've got the ratio of number of almonds to number of raisins, right? So almonds to raisins is 4 to 3. There are 600 almonds, so I'm going to put almonds up on top, right? So how many raisins are there, right? So we can use right? Cross multiplication, 1800 equals 4r. Then we just divide, right? And we're going to get this 450. So we had a decent amount of students able to get that right. Now, this next one was a little bit more difficult because we had the percent increase, right? How do we find percent increase? Percent increase or decrease, for that matter, is going to be, right, the amount increased. So the amount increase over the original, right? So what's my amount increased? Well, my amount increased is going to be a little bit of calculation. I got 130 a month for 12 months, so it's going to be 130 times 12, and then over the original is 750 because that's what I started with. So if I do my 130 times 12, right, we're going to get 1560. Now we could kind of eyeball this a little bit. 1560 over 750. Now you can go ahead and do the whole thing as calculation, but you should be able to say that, if I double my 750, that's going to be 1500. So it's a little bit more than 2, right? And 2 would be about 200, right? Since we're turning this into a percentage. And so it's going to be that little bit more than 2, that 2.08%. So that one was a little bit trickier, right? We had that only 38% get that correct. So what made this challenging? Well, we had to use a ratio to solve the problem, right? So even if it was that 4 to 3, right? We had to know what to do with that. We had to use cross multiplication or find equivalent fractions to find that. So that made that a little bit of a challenge on number 1. And then this percent increase, right? It requires that specific ratio of the amount increased over the original, and that's not provided in the reference material. So they had to go into that problem knowing how to manually calculate the percent increase. And then they didn't even give us just the percent increase, right? We had to do a little bit of work there. Remember, it was that 130 times 12. So we had to do a little bit of a calculation, that 130 times 12, before we could find the actual amount increase. So that added a little bit to the complexity. So what we need to do is, how do we help with that first one? Well, we need to use a ratio, remember the almonds and the raisins, but then use the ratio to find both items in a problem situation, right? So how do we find the number of almonds and the number of raisins? So have them practice finding one or the other given 2 different sets of data. We need lots of extra practice with both percent increase and percent decrease problems. And kind of like I did when I was solving it, have them talk through the reasonableness in percent increase or decrease, right? This 1560 is a little bit more than twice 750, which means it's going to be, a little bit more than 2, or since we're doing percent, 200%. So getting that extra bit of reasonableness will also help students be a little bit more confident in solving these problems. So 7.9b, we're getting a little bit closer to our 50% threshold. We got 45.5%. And so now we are calculating the circumference, right? So circumference equals pi times diameter, but they don't give us the diameter. So we could also use, the 2 pi r, right? And so 2 times pi, and then times the radius of 4.5, right? It's just pretty basic calculation. It's going to be your 28.26. And then we've got the diameter of 90. We need to find the area, right? So remember, our area is going to be pi r squared. They don't give us the radius, they give us the diameter, so we need to cut this diameter in half, and we need to know that it's 90 over 2, so that's 45. So that's going to be the pi, and then 45 squared. We don't have a calculator on the test, so we have to square 45 ourselves. And so that's going to end up getting us, this 45 times 45. That's going to be the 2025. Then we need to basically triple that, multiply that by 3.14. You're going to get this 6358.5. And so what does that mean for us as educators here? So students more often chose the circumference than the area because the diameter was given rather than the radius. Take a look at this one right here. If I'm just given a diameter, I know that circumference, right, equals pi times diameter. So if I'm given the diameter, I'm automatically thinking circumference. And so this answer right here was actually chosen more because that was the circumference of this particular circle. And more students chose that because they weren't necessarily looking at what it's asking for, area. They were looking at what is given, diameter. Diameter means, oh, I'm looking for circumference. So, and then when given the radius, right, students had to choose this particular equation rather than this particular equation. And then obviously we're multiplying without technology. So we've got 3.14. That's quite a few digits behind the decimal that we're going to calculate without using a calculator. So we need to give students our suggestions down here in white. Give them a circle. Have them calculate both area and circumference, given the dimensions that are there, and then note the relationship between the two, right? And we should notice that we can calculate both, but just because we can calculate both doesn't mean we want to calculate both. But that was kind of the challenge, was to just identify what are we looking for, area or circumference. Have them do both so that they can translate between the two. And then have students practice estimating the circumference by tripling the diameter, right? Remember, circumference equals pi times diameter. That's about 3, right? So you could just triple the diameter, or you can multiply the radius by 6, right? Because it's 2 pi r, so 2 pi is about 2 times 3. We could just do some estimation for reasonableness to think, hey, give me the radius, I'll multiply by that by 6. That's going to be close-ish to the circumference. So I'm going to multiply that by 3 if I'm given the diameter. So there's 2 different ways that we can help our students practice reasonableness. 7.3b, we are looking at 47.5% overall mastery here. And we've just got basic problems. Now, this first one, 44%, it's just because we've got all of these mixed numbers, okay? So we've got one roll being 10.75, another roll being, this 12, it's 12 and 10 and 7/8, 12 and 1/4, right? So now we've got to combine those to see what the total length is, right? So we're going to get 10 and 7/8. I'm going to go ahead and make this 12 and 2/8, right? So that's going to be 22 and 9/8. Now it's just keeping that as the improper fraction because now we're going to have to sell 4 pieces of cloth. That's 4 and 3/8, right? But there's 4 of them. So I need to do 4, and then I've got my 3/8. I need to multiply that by 4, right? So that's going to be 16. And then 4 times 3/8 is going to be that 12/8. So I need to do something with that 12/8. I'm going to subtract, take out a whole 8/8 and rewrite that as a whole. So that's going to be, 17 and 4/8. So now I can subtract these two. And that's where having this improper fraction helps. So that's going to be 5, and that's going to be 5/8. And so my answer here is B, but that's an awful lot with improper fractions and mixed numbers. This one was a little bit easier. The outside temperature here, right, is 4 p.m. We need to know that from 4 p.m. to 6 p.m. is going to be 6 hours. It's decreasing, it's negative 2.5 for 6 hours, right? So that is going to be at negative 15. So I'm going to start with my 8 degrees Celsius. I'm going to subtract 15, right? That's going to give me to my negative 7. So that's my answer on that one. And so really, the difficult part about that first one was really those mixed numbers and the improper fraction, and how do we rewrite an improper fraction in a mixed number to make it more of a proper fraction? That was a challenge. And then, there was a hidden number here. The number of hours between 4 p.m. and 10 p.m., there were 6, and they had to figure that out on their own. A little bit more complex here. So we need to reinforce mixed number concepts. This is something we probably don't do enough of with students because they've been working with this for a while. But right, how do we rewrite 5 and 5/3? Right, how do we rewrite that as 6 and 2/3? How do we do that just with an algorithm? How do we do that with pictorial representations, even concrete objects, so that they really see how to switch between the two? We need to give them tons of opportunities to add, subtract, and multiply mixed numbers, regroup them as needed. And then we can have more problems with time intervals. This would mimic that second one because that time interval gives us an opportunity to provide a hidden number, right? Something that they're going to have to calculate, like the number of hours for elapsed time, but not give that to them in the problem situation. So that would help us with that situation. And then finally, we've got 7.9a. Right, we've got overall mastery at 49%. We are solving problems with, okay, volume. So we've got a tent, we've got the shape of a square pyramid, side length of the base's feet is 7, right? So if I'm going to draw my base here, that's 7, that's 7. So I know I'm going to need a base of 49, then I'm going to get my height, and that's going to be 6.6. So once I have that base of 49, right, I'm going to take my 1/3 times my base times my height. And really, to make this simple, we should have done the 1/3 times 6.6, because that's going to be 6.6 divided by 3. So really, it's 4.9 times 2.2, because I could take my 6.6 divided by 3, get 2.2. You're going to get this 107.8. And then I've got a gift box, rectangular prism. But look, they give you the whole volume. So they're going to give you the volume there of, 384. And so that's right there. And then the base has a, square area, right? The B equals 64. So I'm just looking for the height. Well, we need to know that volume equals base times height. So that's going to mean that I've got 384 equals 64 times my height. So I just need to, divide my 384 by my 64, and that's going to give me my 6. So that 34 was a little bit easier. Calculating this pyramid, I think having the decimal made that difficult. Only 39% on number 17. So what does that mean for us? Well, we were given the side length of the base rather than the area of the base. That's always difficult for any type of volume problem, is you need to calculate your own base rather than be given the area of the base on that first one. On the second one, they at least gave us the area of the base. They at least told us that it's 64 square inches, but calculating the base on your own, even if it is just a square, adds another layer of complexity. And then we're used to solving for volume, but now we had to solve for height on that second one. So that made it a little bit challenging for some students. We just need to practice with pyramids. Pyramids are a little bit difficult, right? So what kind of bases can we give them? We give them a square base, a triangle base, a rectangle base, give them all kinds of different bases. Only provide the height and the side lengths so that each time they have to calculate their own base. And then finally, we need to have students with volume solve for multiple dimensions, right? Solve for the base, solve for the height, solve for the side length. In addition to solving for volume, we're used to solving for volume, but we need to have them have extra practice solving for one of these other dimensions as well.